So we were interrupted in the last video, so we were doing the examples. Since this videos cannot be extended more than 15 minutes, it automatically stops. So we had to stop there. So let us again restart the examples. So we are with this example. So here we have taken this particular molecule, and what will be the base value? Base value will be what? It is heteroannular. It is out of the ring, so it is heteroannular, so it is 214, and there are to this conjugation there are two alkyl groups. This whatever you see, okay, the extension part, it is not connected directly to this conjugated double bonds. Okay, so therefore we will not consider it. This one and this one only will be considered, since it is connected to the carbon atoms in the double bonded or conjugation system. So it is two alkyl groups. Now here another thing you have to know, this is the ring and this is the double bond which you are calculating as exocyclic double bond. So exocyclic double bond has a 5 increment, so therefore all this becomes in total. Rest we don't have anything else, so we have total of 14, 214 plus 10, 240, 24 plus 5 is 229 nanometer. Let us go to the next example. This is homoallular. Homoallular has a base value of 253. Now let us count the substitution ring residues on this conjugate system: 1, 2 and 3. So therefore 3 ring residues means 3 into 5 is 15. Now exocyclic means what? This is the double bond exocyclic with this ring. Okay, so exocyclic has a contribution of 5. In total it comes to 270. Third example is a heteroannular double conjugate system. So the base value is 214. So let us count the ring residues: 1, 2, 3 and 4. So 4 ring residues means 4 into 5 is 20. And here you see this is the double bond and it is conjugated system, and it is exocyclic with this is ring. So therefore what you have is, it is an exocyclic double bond and its contribution is 5. In total it is 239. Next, number 4. Number 4, you have a homoannular rings the conjugate system. It is 253 base value. Now what are the ring residues? This is 1, 2, okay, 3 and 4. Only those have to be considered which are connected with the conjugated system. So 4, that is 20. Now here you see this is the ring and this is the double bond. This is the ring, this is the double bond. So therefore you have 2 exocyclic double bonds. 2 into 5 is 10. So total it is 283. Now come to the next one, little more complicated. Okay, you have a three double bonds in conjugation here. So it is heteroannular. This is homoannular. So which one will you consider as a base value? Homoannular. So it is 253. Next, come to the ring residues. This is starting with this one: 1, 2, 3, 4, 5 and 6. Okay, ring residues, you have to count all those which are connected to the conjugated system. Okay, conjugated system, whatever is the number of double bonds, okay, you have to consider all. So 6 ring residues are there. Now come to the next one. What is exocyclic double bonds? If you consider, you see this is a double bond and exocyclic to this. This is a double bond exocyclic to this, and this is a double bond exocyclic to this as well as this. So here you see, if you count, it is having 4 exocyclic double bonds. So you can directly count it as 5 into 4. Okay, instead of counting it part by part. 2 exocyclic double bonds means this one, and this one has been considered. This one has been considered exocyclic to this ring. This one has been considered exocyclic to this ring. So there are first step, it has been shown part by part, and this double bond is exocyclic to this and this. So as a whole you can count it as 4 into 5. Now next is another contribution you have to count here is double bond extension. Okay, so if you see the table here in the last page, you have to remember this total thing you have to remember, means 5 for ring residues. Double bond extension conjugation means if it is a diene and it has been found that it is not a diene here, it is a triene rather, so you have to consider the base value with the diene, that is this is a diene, and the next one, third one, you have to count it as 30 for a ring extension. Okay, if there are more 4 double bonds are there, you have to count it as 2 into 30, that is 60. Okay, so that is the thing. So most very interesting if you really want to learn. So lambda max becomes, in total count all this, you will come up to 333 nanometer. So as there are more extensions, more residues, automatically it has a bathychromic shift, means it is shifting towards longer wavelengths. It is giving you what red shift, and the color is becoming wherever was the base value, it will be coming towards the bathychromic shift, means red shift will be there. So this is not in your syllabus, so we will not go into that. Okay, for double bonds. So if you go to this double bond extended conjugated system, Cs and trans isomers, I think I've discussed this part. Extension conjugated systems. Let me check this part again. This will not be required much. Alpha beta, this is the part which you require. So alpha beta answer carbonyl compounds. Let me check the syllabus once more. This is alpha beta answer conjugated carbonyl compounds, aldehydes, ketones. Okay, so we'll go into this. So for today, I think, is it done? No, we'll have another. So let us finish this part. Okay, so carbonyl compounds have 2 principal UV radiations. The alloweds are, it is pi to pi star transition, and the forbidden is N to pi star transition. So and N to pi star has a ring forbidden transition, so therefore the epsilon is very low. I have discussed this part. And pi to pi star is an allowed transition, the epsilon is higher. So in amides, acids, in amides, acids, esters, and acid halide, the substituent is as NR2, OH, OR, etc. are showing what hypsochromic effect on the N to pi star transition. Hypsochromic effect is due to the inductive effect of N oxygen or halogen atoms, means its lone pairs. Okay, hypsochromic shift we have shown it, bathychromic hypsochromic shift. So it goes to the blue shift. It will be having blue shift. Hetero atoms withdraws electron from carbonyl at carbon and makes carbonyl oxygen lone pairs of electron more stabilized. So therefore, since it is becoming more stabilized due to its involvement in increasing C double bond O bond order, so therefore if it is stabilizing more, the N to pi star transition will shift towards the blue end. Okay, so to 250 range relative to 270 nanometer in aldehydes and ketones. So therefore let us see if we are getting our expected discussion result. Okay, so here we have to know what is the rule. the rule tells us the base value of acyclic alpha beta. Acyclic, not a ring, okay, not a cyclic. So acyclic alpha beta 215 nanometer. If it is 6-membered cyclic, it is 215, same one. 5-membered cyclic, it is 202. Alpha beta unsaturated aldehyde, if it is ketone, it is 215. Aldehyde, it is 210. Alpha beta unsaturated carboxylic acids or esters, it is 195. Okay. Now increment, if there is an increment, then what is the answer? What is the addition? If there is a double bond extension, it is 30. If there is an exocyclic double bond, it is 5. If it is homoannular diene component, it is 39. Okay. Now, since you are having a ring, where is the position? Okay, if the position is alkyl substituent or the ring residue is in the alpha position, it is 10. If it is in the beta position, it is 12. Gamma position, it is 18. Delta position, it is 18. So similarly, if the substituents are there like this and the positions are changing, accordingly the increments will also change. Okay, now let us see what is there here. The solvent, I told you solvent also has a bigger role. Solvent will interact with the lone pairs and accordingly there can be a blue shift or a red shift. Since carbonyl compounds are polar in nature, the position of the absorption bands depends on the solvent used. Hence, solvent correction are required to calculate lambda max. So you have to know what is the solvent. All the above corrections are taken in ethanol. So whatever base values you have been supplied in this table, it is in terms of the solvent is ethanol. But if the solvent changes, for calculating lambda max in other solvents, one must include solvent correction. So other than this, then you have to subtract or add. Water, you have to subtract -8. Okay, subtract 8. Methanol, it's same thing, ethanol. Chloroform, you have to add +1. Dioxane +5. Ether +7. And hexane, it is +11. So you can see if it is more polar solvents, it is what more polar means. Water is more polar, whether chloroform and ethanol are almost same. So whatever these are what less polar than ethanol, and hexane is non-polar, you know that. So if it is non-polar, it is having bathochromic shift. If it is polar, it is having hypsochromic shift. Okay, so therefore it is going to the lower wavelengths. Now let us again see this part. What was the base value in case of dienes? It is 253, right? You remember this one, 253. Now see, such a high base value means it is already having a absorption towards the red end. Okay, but it is aldehydes and ketones, the base value is quite less. Okay, 253 and this 215 quite less. Okay, because of the N to pi star interaction. Okay, so let us take some examples. So what do you see here? What will be the base value? It is alpha beta unsaturated ketone. Is it cyclic? No, it's not cyclic. It is acyclic. So what will be the base value? It is 215. Now to this, what you see here is, here you see there are two alkyl groups in the beta position. This is alpha, this is beta. So beta position means 2 into 12 is 24, and accordingly this is done. It is a ketone, remember, it's not an aldehyde. Next is this one. This is also a what? Cyclic alpha beta 6-membered ring. So it is having a base value 215. Same. It is ketone. It is cyclic 6-membered, same value. So now next is alpha position. There is a substituent. It's 10. Beta position. There is another substituent. It is again having 12, 1, and this is something ketone, we have already considered it. It is not in the conjugate system, so therefore it is not calculated, it is not counted. Okay, next one, it is what? It is a cyclic, 6-membered cyclic ketone. Now it is having 215 as the base value. Now to this, what we have is alpha position.